All right, folks, in this video, I'm just going to briefly discuss something called the Central Limit Theorem. The Central Limit Theorem. Now, this theorem, this central limit theorem, is very important in statistics. It allows us to have confidence in using certain tools, in particular, the z-score table, when we're doing statistical research or when we're using statistics for research. Here's what the central limit theorem says. See how what we did here in this previous video is we took a population of 7, we took a sample size of 5, and we identified that we could have 21 possible samples with a sample size of 5. And we identified all 21 of those samples. We calculated the means of all 21 of those samples. Then we calculated the mean of all those means and the standard deviation of all those means. And we created the sampling distribution of the mean, this frequency, this normal distribution, okay? And that's what the central limit theorem has to do with. Here's what the central limit theorem says. It says that when you do this thing, when you have a population from which you are drawing a sample and you identify a population mean, or you try to identify the mean of the population of possible sample means, when you do that, the distribution of sample means, here's the central limit theorem, the distribution of sample means will take on the normal distribution. They will be distributed according to the normal distribution when your sample size gets larger and larger and larger. So in this case, we had a sample size of 5. Not that big. Of course, our population was only 7, so it's large for the population. But let's say we're dealing with a population of 10,000 of something. The idea here is that you need a larger sample. You can't get by with only a sample of about 9 or 10. Now you can use a sample of 9 or 10, but you're going to have less confidence in your results, in your conclusions. Okay? That in order to have more confidence in your conclusions, in order to assume or believe that the distribution of all your possible sample means, in order to believe that they are more normally distributed or distributed according to the normal distribution, you need to have a larger and larger sample size. And this is why it's important to have a larger sample size instead of a smaller sample size. Now, having too large of a sample size can also be a problem, but that's probably for your second or third statistics class. We're not going to talk about that right now. Okay? So the central limit theorem says that a larger n leads to a sampling distribution of the mean that is closer to the normal distribution. And when you have a large enough sample size that you can be confident that your sampling distribution of the mean is taking on the normal distribution, then you can use your trusty old z-table or some other kind of tool like a computer, or you can use a graphing calculator to calculate your cumulative proportions, just like what the z-table gives you. Okay? So that's the central limit theorem, an important theorem in statistics and something you need to understand in your growth in understanding statistics over all the years and all the classes that you take statistics.